Hello. 2024 AP Calculus, hello. Welcome to the first live review. Hope you're all having a nice night. Ready for some calculus? Exciting stuff. I've hit two technological snags with the first live review. Looks like we got Alex in the chat. Hello. It's a moment in history. Absolutely. Mind-blowing emoji. Dragon fruit. Hello. It's happening. How's the volume? Give me a thumbs up or a like in the chat. Things are good. Snag number 1. My software that I used to use, which is called A-Power Mirror, to essentially mirror my iPad to my computer. It's now $10, or sorry, it's 10 minutes for free now, unless you pay money, which is insane. Hey, what is going on? Dragon Fruit Silly Machines, how's it going? Getting ready to start real soon. 8:35, trying to keep to our 9 o'clock cutoff, but honestly, tonight was just to see if everything's working good, which I've found a couple of snags so far. But we're going to make the best of it. Hope you're having a nice night. Enjoying a little AP Calculus. All right, we're going to jump into things. I'm going to go ahead and attempt to boot up the software. It's called A-Power Mirror. That's what I use to mirror my iPad. If you have a software that can mirror the iPad to the computer for free for any extended time, please let me know what it is, because mine is only limiting me to 10 minutes. I literally have to turn it off and then turn it back on. Oh my gosh, it's Tor Kenyon. Tor Kenyon in the chat. How's it going? We got an alumni, Shakhtar alumni, just tuning into the video. Getting ready for the AP exam, Tor. Ready to go. We're excited. Okay. Things look good on my screen. A Shakhtar veteran, that's right. I just want to check too. I know sometimes YouTube mirrors my things incorrectly, but I'm pretty sure the settings all saved from what last time I went live. Is it backwards to you or is it regular? Just want to make sure before I start writing that you can actually see things. And ooh, my face is in the way. Mr. Shakhtar, go over here maybe. Maybe a little smaller, Mr. Shakhtar. How's that? There you go. Tiny Mr. Shakhtar. Okay, seems to all be good. Great. Oh, the iPad just goes to sleep. That's not what you want to have happen when you're being timed. 10 minutes being timed. We're going to jump in. So guys, the perfect like you. Oh, thanks, chat. The two problems we're going to do today are going to be the continuity problem, which is right here in front of you. And then we're going to do this problem right here, which is the squirrel rate of change problem. I'm going to do these two problems. Hopefully, you did these for homework already if you're in my AP Calculus class. And if you're not, and you're watching this video, you can certainly go and try 2012 AP Calculus problem number 4 right now, and then you can hit play and see how you did. So we are going to jump into this problem. This is the continuity problem. It also, big rip to my stand that I used to write on is actually at school, and I have my laptop on that. So I used to like have the stand and I would write right on that. Now I'm literally using my lap. So it's okay. We'll make the best of it. All right. So we're going to jump into this problem. Let's read the problem. It says the function f is defined. F of x equals the square root of 25 minus x squared. Always inclusive interval here, -5 to 5. Very important to consider that domain. Always consider that domain. We're going to jump right in with a derivative. We have to take a derivative. So letter A, oh, nice. We are on the eraser. That's not great. So A is find the derivative. The derivative of any radical, of course, is 1 over 2. And then times that radical. So this is going to be 25 minus x squared to the -1/2 power. And then we have to multiply by the derivative of the inside. The derivative of the inside is -2x. If I clean this up, the 2 and the 2 cancel. My -x is going to be on the numerator. And my denominator is going to be this square root, which is 25 minus x squared. This is my first derivative, so part A is done. Okay, we can check the scoring rubrics a little later. I think for now it might be best to just simply do the math. B, write an equation of a tangent line to the graph of f at x equals -3. All right, so in this situation, just like every tangent we've ever done, we need a slope, which is f prime of -3, and we need a point, which would be f of -3. All right, so looking at the function of f of x is the square root of 25 minus x squared, and this is f prime of x. So I'm just going to go ahead and plug -3 in. Awesome. Wait, can't you join with a school account? I actually set this up to be public because I didn't want to have anyone kicked out of the stream, but of course, I don't think that's going to be an issue for now. So anyways, we're finding the slope of -3. We're finding the point at -3 using these two functions. So derivative first would be 3 over the square root of 25 minus -3 squared, which is 16, which is equal to 3/4. So the slope at -3 is 3/4. And then we have the actual function value at -3, which is just the denominator, the square root of 25 minus x squared, which again is just going to be the square root of 16, which is 4. So the tangent is going to be y minus 4 is equal to 3/4 x plus 3. All right, so that's my tangent right there. And we are now building towards figuring out, actually, I think that's it. Write the equation for the tangent. Yeah, that's it. We don't have to do anything with it. Just be aware that a lot of times in these AP exams, they ask you to use the tangent to approximate a value of the original function. You take that value of x, you plug it into the tangent, and then as we did in class today for my B period, and we will do on Monday with my E period, under over approximations. Very common questions. All right, C, let's read. C says, let g be the function defined by g of x equals, so f of x between -5 and -3 inclusive, and then x plus 7 between -3 non-inclusive, 5 inclusive. Is g continuous at x equals -3? Use the definition of continuity to explain your answer. B period. I was chatting with you guys today about this. I'm really confident that they're going to have some type of continuity question because they haven't had that in a while. So I definitely want to take a look at this. From which homework was this? This is not the April break homework. No, this is actually the homework I assigned the class on, I believe it was Monday. No, we had PD day Monday. It was Tuesday. I assigned these two FRQs. And then yesterday I assigned potato and whatever that differentiability one was. These two are from 2 nights ago. So Tuesday, if you check on the AP Prep doc. Okay, so let's get a reminder of what exactly the continuity test says, okay? The continuity test says that the limit as x approaches some value, in our case, -3, okay, has to equal, or of g of x, has to equal g of -3. The continuity test says the limit has to equal the function value, and that makes continuity. This one right here, the limit, of course, we learned in Unit 2, is you have to find the limit from the left and the limit from the right. So essentially, we have to prove 3 things are equal here. The limit from the left, so I'm going to go ahead and start the limit from the left, okay, of g of x. We have to prove that that's equal to the limit from the right, which is also equal to the function value. So using the left-handed limit, if you guys are looking at the function, left, I'm right here, okay? Left of -3, so I'm going to be using f of x. So what I'm going to do to find the left side limit is do the limit as x approaches -3 from the left of g of x is equal to the limit as x approaches -3 from the left of f of x, because the function is defined to be f at that point. And that's just going to be the square root of 16, which is 4. I have to do the same thing for the right. So the limit as x approaches -3 from the right of g of x. Now, if I go up and I look at my function, I believe that's the linear, which now in this case, I'm defined on this side, which is x plus 7. So I'm going to go ahead and do x plus 7, whoopsies, which is the limit as x approaches -3 from the right of x plus 7. No parenthesis there, not sure why I added it. Deleting is equal to -3 plus 7, which is 4. Okay, so far so good. What I've essentially proved is the limit from the left is equal to the limit from the right, which now means that the limit in general as x approaches -3 of g of x is positive 4. The only thing left to prove is that g of -3 itself is equal to positive 4. And of course it is, because that's equal to f of -3, which I've done many times on this piece of paper or iPad now, and that's 4. And then I'll say, therefore, g is continuous at x equals -3. And I've answered the question. Okay, so far so good. We have finished A, B, and C on that question. Now we're looking to D. And we're going to go ahead and get a jump start with D, getting a read first. It says, find the value of the integral from 0 to 5 of x root 25 minus x squared. Can you integrate the product of two functions? No, you cannot. You must use a u substitution. So let's go ahead and see if we can do this. The question was the integral from 0 to 5 of x square root 25 minus x squared dx. Okay, so I'm going to use a u sub here. I'm going to let u be 25 minus x squared. If you need a little refresher, the u is typically the inside of the more complicated layer. Okay, you've got like x on the left, you got square root 25 minus x squared on the right. It's clear the square root function is more complex. So the innermost piece of that is going to be what we let our u to be. All right. So then if I take the derivative of both sides, I get du is equal to negative 2x dx. And if I isolate dx, I get negative 1 over 2x du equals dx. And before I actually go and make that substitution, I'd like to switch my bounds. Because I let u be 25 minus x squared, okay, I need to switch my bounds. I need to plug my upper bound. So my upper bound will be 25 minus 5 squared, which is 0. And my lower bound will be 25 minus 0 squared, which is 25. This is my upper. This is my lower. Okay? So now I'm going to go ahead and put everything inside my integral. And we're going to see how we're doing. So integral 0 to 5 now becomes 25 to 0. Inside, I have the square root of just u, du, because what's going to happen is my x is going to cancel with my x in the denominator. And I've got the negative 1/2 constant to be pulled out of the integral. And this is what I've got. Before I start integrating, I'm actually going to swap my bounds, which causes a negative to be removed from the integral. So this now becomes 0 to 25 of root u du. Okay, cool. So I'm going here. I'm going add page. Hey, look at that. I can add an infinite number of pages. Amazing. Amazing. Okay. And now I need to actually integrate this, all right? So I'm going to go ahead and integrate u to the 1/2. We're done? Oh, yeah. Free trial. Reconnect. Oh, at least it gives me a button to reconnect. I guess that's kind of nice of them. Do I need to like sponsor A Power Mirror or something? Maybe it worked. If I mention A Power Mirror in my classes, will you give me, oh, almost got it. There it goes. Will you give me a free premium membership, A Power Mirror? Trust A Power Mirror for all your casting needs. Schachter approved. Free pages. That's right, Dragon Fruit. Free pages for life. All right, I definitely hit the appropriate button. It is currently buffering. You got that little wheel spinning, right? No one likes the wheel spinning. No one likes that wheel spinning. We're still spinning that wheel. All right, that's cool. We're going to solve this integral in a minute. 10 minutes. And you know, this is actually kind of a funny thing. If only it was 15 minutes, because then it would cut off every time the FRQ timer would go. You know what I mean? That'd be really funny. All right, we're going to try. It says unable to connect. That's okay, though, because we're going to try a hard stop and start again and connect. All right, yeah, it's no longer listed as a screen mirroring device. So what we're going to do is hard reboot A Power Mirror. All right, A Power Mirror is right here. Do a hard reboot. Hope you guys are having a nice night. Anyone go to the NHS induction ceremony? If so, hope it was good. Ah, it's back as a casting device. Yes. Yes. All right, we're waiting patiently. Yes, it's good. It went through. We did it, team. We did it. We're going to full screen it. Boom. Here we go. And don't worry, I only have to do that every 10 minutes. Better than every 2, I guess. All right, now we're going to actually solve this. Square root of u, eraser, of course. Square root of u is u to the 1/2 power. So if I have to integrate u to the 1/2 power, I have to add 1 to 1/2, which would make 3/2. So this would be 2/3 u to the 3/2 power from 0 to 25. Okay? Now, here's the thing that a lot of students make mistakes on. Very important. Very important. You're not going to plug u back in. This whole square root of 25 minus x squared never goes back inside this u. It's because I switched the bounds to be u bounds. So I'm actually going to solve the problem with just this expression, leaving u inside the expression. So this is going to be 1/2 times. Now this is 2/3 u to the 3/2. Now I have to do the upper bound minus the lower bound. Luckily for me, the lower bound is 0. So I actually don't need to do it at all, because if I raise 0 to the 3/2 power, it's 0 times 2/3 is 0. The whole lower bound will actually get canceled. Okay? So instead, I just need to do this one. This is 1/3. 25 to the 3/2 power. Boy, 25 square rooted is 5, and then cubed is 125. Final answer, 125 over 3. And I think with that, we finished FRQ number 1. Exciting stuff. I'm going to pause for any questions in the chat on FRQ number 1. We have approximately 11 minutes to complete FRQ number 2. I'm not concerned about it. If we have to go over a couple, then I can also try to be brief. All right, I think we're good. Is it better to check as you go or check at the end? Silly machines, I'm not entirely sure. I think it depends on the FRQ that you do and how much time you feel you have. So as you're doing an FRQ, if you think you're progressing at a pretty decent rate, I think it's worth checking to make sure your answer seems logical before moving forward. However, if you feel like you're stressed for time, I think having at least a shot to solve every question is better than obsessing over maybe the parts A, B, and C to be completely correct before moving to D, because you're setting yourself up to just be really stressed to try to finish letter D. So I would say it depends how you're feeling on time, but if you're okay on time, do it as you go. If not, save it for the end. Cool beans. Guys, this is the second problem we're going to take a look at tonight. It's about a squirrel. It says a squirrel starts at a building T equals 0, travels along a straight horizontal wire connected to building B. Between 0 and 18, the squirrel's velocity is modeled by a piecewise linear function defined by the graph above. Super important that you notice that this is the graph of V, which represents the velocity of the squirrel. So if you're asked any questions about its acceleration, you need to find the derivative or the slope. And if you're asked any questions about the position, you need to go backwards and integrate. Okay? Let's go ahead and see what this question has in store for us. A, at what times in the interval between 0 and 18, if any, does the squirrel change direction? Well, just simply look at the picture. The squirrel is going to change direction wherever this velocity changes sign, right? Because in a positive direction would be like moving right or up. Actually, I think it did say horizontal, so we are moving right, the squirrel. So a positive is moving right and a negative is moving up. So this particular squirrel is going to change direction whenever its velocity changes sign, which is at T equals 9 and T equals 15. And I'll write since, because it says give a reason, the velocity changes sign. Okay, since velocity changes sign, great. And Justin's question for the previous FRQ, how do you get the bounds of integral for D? So I'm going backwards to D for a minute, just reading a question in the chat. So how do you get the bounds? The original question gave you the bounds 0 and 5, okay? Now, once you create a U substitution that U is equal to 25 minus x squared, all you have to do is one at a time, you plug those bounds into your related equation, and you get the new bounds, which are going to be what I call U bounds, okay? So for example, if you take the upper bound of x, which is 5, you plug the upper bound of x, 5, into the equation for x, you get the answer of 0. So your new upper bound for U is 0. And then likewise for lower bounds, you have to plug the 0 in. And that's how we're going to get 25. All right, silly machines, boom, there you go. Did I miss that question? It says Justin's question. Looking back, there's not that much chat. I don't see anything Justin's trying to. I don't know. Might just be a thing that I missed for some reason. Okay, but I hope that answers your question, silly machines. We're going back to the squirrel. We finished A. We're reading B. At what time in the interval 0 to 18 is the squirrel the furthest from the building? How far from the building A is the squirrel at that time? So essentially, furthest from the building means like the distance is equal to essentially the smallest possible, right? Because we're trying to be the furthest from the building. So actually it would be the largest possible, not the smallest, since we're trying to be far. So we're trying to essentially figure out when the distance is as far as possible. Well, that to me sounds like an absolute minimum or maximum. In this case, maximum. I keep saying minimums, but this is absolute max. We're trying to find the biggest possible value, okay? I used pink for correction. I want to use red for work. So like any absolute question, we have to first find the critical points, and we have to find the endpoints. So looking at the critical points first, the critical points we just found the previous question to be 9 and 15. The endpoints in our interval are 0 and 18. So I essentially now need to do a little bit of work. I need to find if the t values are 0, 9, 15, and 18, just putting them in numeric order. Where is the distance, or I guess position's a better phrase. Where's the position? The position, I need to find the biggest possible position value, okay? So in order to do this, I don't have a position function. I have a velocity function. But the nice thing about this particular velocity function is that it's geometric, meaning I can find the area under the curve. And I know that the integral of velocity is position. So I know that the area under the curve is equal to the position value at these numbers. For the sake of time, I'm only going to do one of them out. We don't really need to do 0 out because the position of 0 is 0. But I'll do 9 real quick, and then I'll kind of just write down the answers for the other two, and you can try them on your own. The position at 9 using this right here, here's 9. So what I have to do is find the, essentially, area of this trapezoid, okay? Now the area of a trapezoid, area of this trapezoid, is equal to 1/2 times the height. The height of the trapezoid is 20, right? Times the sum of the bases. Now the bases are the two parallel sides. This is base 1. This is a length of 9. This is base 2. This is a length of 7. Take away 2, which is 5. So the answer to the position of the squirrel at 9 is 140. Just computing this. And I believe this is a calc active question. I'm pretty sure we're on number, it says no calculators allowed. Okay, no calculators allowed. I mean, I did it ahead of time with the calculator, but it's 1/2 times 20, 9 plus 5. It's not too bad. 14, and then half of 20 is 10, and then times 14, you get 140. So not too crazy. Once again, I'm just going to kind of expedite for the sake of time. 90 and 115 would also be geometric areas to calculate. Okay? All right, going back up to read C. Find the total distance the squirrel travels during the time interval between 0 and 18. Okay, so this wouldn't be too hard. I know that total distance is the absolute value of velocity, like this, right? Integrated. So I know that that's equal to the total distance. So not the absolute value of the integral, but the integral of the absolute value. So I know in order to calculate total distance, all I have to do from 0 to 18 is simply find the absolute value of the velocity dt. And this is going to equal essentially all those values, but all positive. So the work that I just did in the previous question, all positive. Check my work, but this should come out to 215. Okay, so we're looking at all those regions, all positive. So we got some questions yet. So on this one, I didn't really write down the values. I just used the logic that the area is much larger at 9 and compared it to the other two versions. Alex, I think that's totally fair. Let me give you a sample response of what I might say if I were to do that. So in that problem, you're looking at all these possible candidates. And as you can see, from 0 to 9, there's a tremendous amount of positive area that's accumulated. You have a small amount of negative area accumulated from 9 to 15, and then even more positive area to add from 15 to 18. Alex, I think you're fine as long as you say something like that, where you have a lot of positive area from 0 to 9 and then 15 to 18. It outweighs the value from, oh, there it is again. I'm just going to keep talking while we try to finagle it, but it outweighs the value of the, I'm going to do a hard reboot too, of the negative region. And it might be worth noticing, Alex, in saying this, but I would list the values, right? So even though you didn't make a table, I would make sure you note all the critical points and the endpoints and talk about 0 can't be because there's no positive accumulation. 9 could be, but looking at the, or actually 9 is, but, the other one, 15, it has negative area. And then you could say that at 18, since there's more negative area accumulated from 9 to 15, as there is then gained from 15 to 18, the value at 9 would actually be larger than the value at 18. So Alex, if you say something like that, I think that is a wonderful answer. Okay, trying to boot this up again. Ooh, can I check this out? All right, yep. I don't know if I can do that. Here we go. Boom, there it is. All right, that makes sense. Thanks, perfect. Love it. Okay, it's working. It literally just disappeared, but is it working? That's all I care about. Oh yeah, here it is. I just got buried on this monitor. What you doing over there, buddy? All right, solid. Let's wrap this problem up. That was letter C. We're now looking at letter D. All right, we're doing good. Letter D says, write expressions for the squirrel's acceleration, velocity, and distance from the building A that are valid between 7 and 10. Okay, this is going to be interesting. The first thing I have to do is do acceleration, which I think is pretty easy. Now I'm going to get rid of all this noise. Bye-bye. Delete. Acceleration is just the slope of velocity. So if I'm on 7 to 10, I'm talking about this interval right here. Okay, and so all I really have to do is just calculate the slope, which is going to be your 20 plus 10 is 30 divided by your 7 minus 10, which is -3, which 30 divided by -3 is -10. So I'm just going to go up and write that the acceleration, this is part D now, the acceleration on the interval 7 to 10 is 20 minus -10 divided by 7 minus 10, which is -10. Okay, that's -10 right there. Oh, now my message saying that I only have 10 minutes remaining is currently covering my chat. That's really funny. All right, chat, we're going to take a pause until I finish this and close the app. Okay, so I have the acceleration is -10. That's not too bad at all. That was one of 3 questions asked. Now, I have to find the velocity. Now, the velocity on this interval is just going to be, some kind of function. Now, I have some flexibility here. I can pick any point that I want to and plug that point with the slope into a formula. So I'm going to use 7, 20, and I'm going to say that my slope is -10. Okay, so this is y minus y1 is equal to mx minus x1. Okay, and then if I isolate this thing right here, it's going to be y equals -10t plus 90. All right, so that's the second thing. So this is number 1. This is number 2. I have acceleration and I have velocity. Now I just need to find position, okay? Now I need to find position. Well, here's the problem with position. The position, since I used this right here, 720 was the point that I picked in that interval. So I'm going to go ahead and try to find the position at 7. The problem is I have to go back and do the geometry again because position isn't given to me. So I need to find the actual geometry right here at 7, which again would be 1/2 times the height. The height is 20. Base number 1 runs from 0 to 7. It would be 7 units. Base number 2 runs from 2 to 7. It would be 5 units. So it'd be 1/2 times 20 times the sum of 5 and 7, which, if I did my math correctly, comes out to 120. That's just a point, though. Right, the position is a lot harder than it leads on because I only have a coordinate point. Well, if I have a coordinate point, I want you to think about that coordinate point as the initial condition, or the initial condition, as I call it. And what you have to do is build the position function, build it using that coordinate point. So we say it's the y value of the initial condition. By the way, this is from the Fundamental Theorem of Calculus unit, this particular piece, and that was 5.4 in our text. Okay, very important to review this. So it's 120 plus the integral from 7 to t of the velocity, dummy variable. You can't use t because t is in the equation already. All right, so now we're just going to actually compute this. So this is 120 plus, now this is actually going to be the integral from 7 to t of the function I already created in v of t right above. All right, and now I just need to actually go and solve this thing. So x of t is equal to 120 plus, so I have to actually take the integral. Oh my gosh, I have no respect. Oh, I didn't respect calculus. Oh no, I see the chat moving down. I can't see it because the message is blocking it, but I'll view it in a minute. I assume it's that I forgot my respect. Anyway, so now taking the integral, this is -5s squared plus 90s, and this is evaluated from 7 to t. And then we're going to just do a little arithmetic here. So the actual position function is going to be 120 plus. Now I'd have to first I'd have to plug t in. So it's just this. But then I'd have to minus out the value of me plugging in 7. So this is going to be -5 times 7 squared plus 90 times 7. Okay. Now, I think this problem was a little fast. So right here is probably where we're going to do a little bit of arithmetic, right? This said no calc. So we're going to have to dive into that. Final answer when you're done. If you're trying this on your own, this is what I got when I did it. All right, so you can try to just kind of multiply all that out and see how it goes. I'm going to leave that up for another second, and then I got to close this message because it's super annoying because it's literally covering the chat. Okay, closing. No, it won't even let me close it. That's actually so funny. Oh, there it is. There it is. You see that? It's hidden. Look at this. Like, where is it? I don't know. I don't see it. And then you hover over this. Oh, my gosh. There it is. All right. Closed. Yes, we can see the chat. All right. Let's catch up on the chat. We did that. Dummy variable can be anything, right? Yeah, silly machines. Dummy variable can be anything. I recommend S for Schachter. Yeah, it just can't be like the base variable. That's right, Alex. Yep. So it's just whatever the variable is in the integral, it has to be anything other than that. Okay? All right. Last call for questions. On our first ever live review, we did some good stuff. We did 2 FRQs, and I think there's definitely room for some more live reviews now that we got all the tech working again. Just a small snag. We have to do it every 10 minutes, but I don't think that's the end of the world. At the end of the live review, 14 live viewers, 4 likes, $715 worth of no, never mind. Just kidding. Please don't give me money. I already told you that. Get in trouble. Got the right answer to D, except just use the antiderivatives. All right, Alex. That's a good partial credit, ownership right there. You're going to get a lot of points for that piece. Cool. All right, everyone. I hope you enjoy the rest of your night. We'll do another live review maybe next week, and then maybe one the weekend after that, but we're getting close to AP exams. So life is good. Enjoy the rest of your night. And now you're two FRQs additional for studying. It's good stuff. All right. Good night, all.